Question number 4. There are two balls, A and B, each with velocity of 25 centimeter per second and 15 centimeter per second. They are moving in the opposite direction on the table, so the balls collide with each other and bounces off. So the mass of ball A and B are 20 gram. So the mass of ball A is 20 gram, that is 0.02 kilogram, and mass of ball B is 25 gram, that is 0.025 kilogram. Okay. All right, so now we have to calculate the final velocity of ball B and its direction if the final velocity of A is 10 centimeter per second. So that is, since this is just per second, so we can just directly do 10 times 10 negative 2 meter per second. Okay, so you can just directly do it that way lah. Okay, so now the initial velocity. So the initial velocity of ball A is to the right, so it is positive 25 centimeter per second. And we have the initial velocity of ball B will be negative because it is pointing to the left. Okay, now what else can we extract? So based on the diagram here, we know that this we will need to use the x and y component lah to solve this question. Okay, so we have the y component here, x component here, and this is x, this is y. Okay. All right. So now we have to find this VAY, this is VAX, this is VBX, this is VBY. Okay, so for the let me just think. Okay, so for VA, sorry everybody. So we have the VAX is equal to VA cos 35 degree. Sorry, I forgot the direction. Since it is pointing to the left, it should be negative. So negative VA cos 35 degree. Then VAY is equal to positive. So that is VA sine 35 degree. Okay, so now for VB pula, we do not have the angle, so we need to just write it as VBX lah. Okay, and VBY pun sama juga. Kamu just plot in, substitute in the equation as it is. Jangan letak angle. Buat macam ni saja. Alright. So now we have to do for both x and y component. So let's do for x-axis dulu. So for x-axis, we have, before that, we are going to use the principle of conservation of linear momentum. So that is, you have to write down the equation dulu baru kamu dapat marka. So that is MA UA plus MB UB equal to MA VA plus MB VB. Okay, so you always remember to write down the formula dulu. Okay, so MAUA, so this is gonna be for the x-axis. So for the x-axis, MA is, can I just write copy dulu supaya can just write x somewhere at the bottom. Malas mo tulis balik. So this is x, mass dada. Untuk velocity saja. Okay. So MA is 0.02. So please refer here lah the information yang kamu sudah extract. So MA is 0.02. UAX is, okay, so please remember that this is happening horizontally. So this is your x component, initial velocity untuk x component lah. Okay, so UAX is 25 times 10 negative 2 plus with MB, which is 0.025, times with the initial velocity for ball B, which is negative 15 times 10 negative 2, equal to 0.02. The final velocity is 10. I should just write down 10 pula supaya kamu ndak lupa. Where did I get 10? It's from here lah, it's given. 10, aduh lupa lagi. It should be 10 times 10 negative 2 lah. Okay, jangan lupa it is centimeter. Ataupun kamu just boleh write it as 1, 2, 0.1 lah. Okay, I should do that, right? 1, 2, so it is 0.1. Okay, so this 0.1 cos 35 degree plus dengan 0.025 times with VBX, which is the final velocity at the x component. So we can actually find the velocity at the x component using the x component itself, using the information for ball A in the x component lah. Okay, so you will get VBX equal to positive 0.116 meter per second lah. Okay, did I forget anything in the x component? Yes, I forgot the negative. So please remember to put negative for this one. Sticker. For this VAX, which is this one, negative. Okay, I'm just gonna let it equal to 0.1 lah. Just so that you don't get confused. Where did I get the 0.1 to? Okay, so that is your x component. Now we have to consider the y component juga, because we don't have the component y untuk car B, which is the final velocity untuk car B lah. Okay, so let me just paste this. So we have y, 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 and y. So MA again is 0.02. Initial velocity untuk y component is 0 plus, basically it will be equal to 0 juga di sini. Tapi tulis je lah. Okay, so 0.02. VAY is just going up, so positive 0.1 sin 35 degree plus 0.025 VBY. Okay, so from there you should get the final velocity at the y component to be equal to negative 0.046 meter per second. Okay, this is not the end of it. Remember, you have to find the magnitude. So because velocity is a vector quantity, so you have to calculate the magnitude lah and direction. So the velocity is equal to 0.125 meter per second. And lastly, the direction, which is shift tangent Vy over Vx. So you will get 21.6 degree. Since VBY is negative, VBX is positive, this is below positive x-axis. Okay, alright, so that is the solution for question number 4.